Good morning, Amma. This is Naresh, lecturer from DVR Academy. Today, I would like to deal with the relation between the Kp and Kc by choosing a reaction. Amma. First of all, we would like to keep for the what is the equilibrium constant. So basically, equilibrium constant is nothing but the active concentrations of the products divided by active concentrations of the reactants. Amma. Whatever number of products will be there, you have to just product it. Even in the case of the reactants also. So therefore, basically, Kc is equal to concentration of NH3 power 2 divided by concentration of N2 and the concentration of H2 power 3 m. Actually, the stoichiometric coefficient present stoichiometric coefficient present behind the reactants or products that will be raised to the power. They will be raised to the power. So this is the value of Kc for this equation. Now they want the value for Kpm. Kp will be equals to partial pressure of NH3 power 2 divided by partial pressure of N2 into partial pressure of H2 power 3 m. We know that according to ideal gas equation, PV is equal to nRT. So therefore, P is equal to nRT divided by Vm. And at the same time, N by V, number of moles divided by volume, you can consider this as the concentration. So C into R into T. So therefore, in terms of this one, Kp is equal to, in presence of P and H3, I would like to substitute this one. What is that particular value? Concentration directly I am taking. Concentration of NH3 power 2 into RT power 2 divided by concentration of N2 into RT into concentration of H2 power 3 into RT power 3. So therefore, that will becomes concentration of NH3 square or power 2 divided by concentration of N2 and the concentration of H2 power 3 into RT square divided by RT power 4. So therefore, that will becomes, now I can consider this as is equals to the Kc. So therefore, Kc is equal to RT power 2 minus 4. 2 minus 4. That I am continuing here. Therefore, Kp is equal to Kc into RT power minus 2 m. Hence, what is the meaning of this one? Kc is greater than Kp. Kc is greater than Kp. And finally, what is the general relation between Kp and Kc? Kp is equal to Kc into RT power delta n. This delta n will decide whether Kp is greater than Kc or Kc is greater than Kp. In this particular equation, which is nothing but Haber's process for the synthesis of ammonia, here Kc value is greater than Kp because the number of moles of gaseous products are less than number of moles of the gaseous reactants. Hence, in this process, Kc is greater than Kpm. Very simple. And what is the other term? What is the another reaction? Just a minute. We will see that also. For example, now I am taking SO2 gas plus half O2 gas that gives rise to SO3 gas. Contact process for the preparation of sulfuric acid. Here also, number of gaseous products, that is the 1 mole. But this side, this is the 1 mole and this is the half mole, 1.5 mole. So the number of gaseous moles of reactants are greater than number of gaseous moles of the products. So therefore, here also Kc is greater than Kp. Kc is greater than Kp. Then few equations will be there. Perhaps, for example, 2NOCl gas, that is on decomposition, 2NO gas plus Cl2 gas. For this equation, we have to write Kc and Kp. You just try for it. This is just an hands-on practice. It will be very easy. Kc for this one equal to, Kc is equal to concentration of NO power 2 and concentration of Cl2 divided by concentration of NOCl power 2 amma. The same thing, Kp is equal to partial pressure of NO power 2 into partial pressure of Cl2 divided by partial pressure of NOCl power 2. So now what will be the relation between Kp and Kc again? So therefore, Kp is equal to concentration of NO power 2 and the concentration of Cl2 divided by concentration of NOCl power 2. NOCl power 2, and that implies here it will be RT power 3 divided by RT power 2. So therefore, Kp is equal to Kc into RT power 3 minus 2. So that implies Kp is equal to Kc into RT. Definitely the value of Kp is nothing but product of Kc into universal gas constant into temperature. So therefore, Kp is greater than Kc. Kp is greater than Kcm. Then what about the another condition? For example, I will give you one small equation. You just tell me what will be that. H2 gas plus I2 gas that gives rise to 2HI gas. This side you are having number of gaseous moles. N is equal to 2 moles. And here also N is equal to 2 moles. Both sides we are having the same value. Hence delta N is equal to number of gaseous moles of products minus number of gaseous moles of reactants will be equal to 0. So therefore, Kp is equal to Kc into RT power delta N. This delta N value will be equals to 0. So Kp is equal to Kc into RT power 0. That means Kp is equal to Kc. Kp is equal to Kc. So finally, what is our conclusion? If delta N is equal to 0, at that condition, Kp is equal to Kc. If delta N is greater than 0, or at least we can say delta N is equal to positive, at that condition, Kp is greater than Kc. If delta N is less than 0, means delta N is equal to negative, then Kc is greater than Kp. So this is the final conclusion in order to produce the relationship between the Kp and the Kcm. Yes. So the continuation for this one is Arrhenius concept of acids and bases. Arrhenius concept of acids and bases. So Arrhenius is the scientist. He only made the difference between the acids and bases. Okay. Now, according to our primary conception, we know that if somebody who turns blue litmus into red litmus, that is the acid. Somebody who turns red to blue, that will be the base. Now we are moving into the some deeper side. So this Arrhenius has classified substances into acids and bases. So who are the acids? The substances which release H plus ions, in aqueous solution. So the active species in the case of the acids is the H plus. And at the same time, the substances which release OH minus ions, in aqueous solution. Those are called as the bases. So who will be the examples? For example, if you are having HCl and that has been in aqueous condition, that will be dissociated into H plus aqueous plus Cl minus aqueous. And now the condition is, if you are not having any aqueous condition, if you are not having any water, definitely you will not get this H plus. Dry HCl is not an acid. So if somebody want to release H plus, there should be some criteria. So the substance which will release H plus in aqueous solution, that is the acid. Whereas in the case of base, I am having NaOH aqueous amount that will be dissociated into Na plus aqueous plus OH minus aqueous. So here active species is the OH minus. Here active species is the H plus. The Cl minus and here Na plus, they both are spectators. Whatever be the acid. For example, HCl is the hydrochloric acid. We may have HNO3, nitric acid. We may have H2SO4, sulfuric acid, HBr, hydrobromic acid, HCN, hydrogen cyanide, formic acid, which is an organic acid, acetic acid, benzoic acid. All these acids are there. The only component common among all these acids is H plus. Whereas bases also, which is the caustic soda NaOH, caustic potash KOH, lime water, calcium hydroxide as glycolide, milk of magnesia MgOH twice, and ammonium hydroxide NH4OH, calamine, zinc hydroxide, malachite CuOH twice. The only thing common of all these is nothing but the OH minus. So now I am considering all these are bases, all these are acids. Okay. Again, these acids have been classified into two types of, depending upon degree of dissociation and the number of H plus produced. Acids again classified into strong acids as well as weak acids. Whereas bases also, ఎవరు H plus ఎవరు OH minus ions ఎక్కువ రిలీజ్ చేస్తారు అండ్ ఎవరు ఫాస్ట్ గా డిసోసియేట్ అవుతారు. On that basis, again, bases also two types, strong bases and weak bases. Strong bases and weak bases. So what is the classification criteria for the strong and weak? So here, first of all, my point is, which dissociates to maximum extent. టు మాక్సిమం ఎక్స్టెంట్ అంటే ఎంతవరకు డిసోసియేట్ అవ్వాలో అంతవరకు డిసోసియేట్ అవుతుందమ్మా అండ్ ప్రొడ్యూస్ లార్జ్ నెంబర్ ఆఫ్ H plus ions and produce large number of H plus ions. So generally, mineral acids are strong acids. Mineral acids are strong acids. Who are the mineral acids? C1 only. HCl, H2SO4, HNO3, like this. All these are mineral acids. They obtain from the minerals. Next one, weak acids. So what is the definition of the weak acid? Which dissociates partially. Which dissociates partially and produce less number of H plus ions. Produce less number of H plus ions. Generally, equilibrium. Who will participate in the equilibrium? Those which are weak acids or weak base, they will only participate in the equilibrium because their dissociation is not 100%. They will definitely exist in the format of the equilibrium. So basically organic acids. Organic acids are weak acids. So the best example for this one is formic acid, acetic acid, hydrogen cyanide, like this. So I told you equilibrium. Now how it will be equilibrium? CH3C double bond OH, that will undergo the reversible process. It will be CH3C double bond O minus and H plus. Aqueous condition. In aqueous condition. This is also will be done under aqueous condition only. Whereas in the case of H2SO4, they will not exist in equilibrium. It will be dissociates into 2H plus aqueous and SO4 minus 2 aqueous. 2H plus aqueous and SO4 minus 2 aqueous. Now, moving on to the bases, moving on to the base concept. So same scenario kada base lo kuda ఎవరైతే ఎక్కువ నెంబర్ ఆఫ్ OH మైనస్ ఇస్తారు, ఎవరైతే ఫాస్ట్ గా డిసోసియేట్ అవుతారు, we will consider those substances as strong bases. Same point. So bases which dissociates to maximum extent. అంటే రివర్సబిలిటీ రాదన్నమాట. Which dissociates to maximum extent and produce large number of H plus ions and produce large number of H plus ions. And produce large number, not H plus ions, I'm sorry. And produce large number of OH minus ions. So who will be generally alkaline hydroxide, alkaline earth metal hydroxide, they will be. Means NaOH, KOH, CaOH twice like this. Whereas weak bases, same story, which dissociates partially, and produce less number of OH minus ions. And produce less number of OH minus ions. So basically they will be ammonium hydroxide, which is window cleaner. Zinc hydroxide, calamine, CuOH twice, copper hydroxide. So here the dissociation of NH4OH aqueous will exist in equilibrium. That will be NH4 plus aqueous plus OH minus aqueous. Whereas in the case of strong bases, KOH, there will not be any equilibrium. KOH gives rise to K plus aqueous plus OH minus aqueous. So this is about the simple concept of the Arrhenius theory of acids and bases. Then finally, the reaction between acids and bases, that is called neutralization. Neutralization. So what is the neutralization? For example, HCl aqueous plus NaOH aqueous, that gives rise to NaCl plus water. This is the neutralization reaction. But actually the active components in the case of HCl, H plus Cl minus. In the case of NaOH, Na plus and OH minus. The reaction between H plus and OH minus that will produce the water, that is the neutralization actually. Here sometimes Na plus may be there, sometimes K plus may be there, sometimes SO4 minus 2 will be there. That is not the matter about who are there. But the only concept important for us is the reaction should be between the H plus and the OH minus that leads to the complete neutralization. Okay, Namma? Thank you.